crazy, man.
Well, you like it or bad? Good or bad?
Yeah, I've never done this before.
All right. Well, the good news is it's painless. The bad news is I'm not getting naked, so don't ask.
Damn it.
All right. So how you been doing?
Not too bad, man. It's quite a bit to go over.
It's a couple of things here and there. Yeah. How you been spending enough time studying or no?
Not really.
Yeah. Yeah. How do you
I
feel?
got two. I got two kids, so you know how that goes.
I know exactly how that goes, man. Oh man, do I? Ugh. What kind of questions do you have? I mean, do you have a particular area that you feel like you need to focus on? You got any specific uh, sections or examples or anything? Or
Yeah, I had some stuff written down here. On that practice test you gave me here, there's a question 3. I'm having an issue with the dwellings here, and it says, there's a 25,117 square foot house. Considering no other loads, how many 120 volt 15 amp circuits are required for this residence?
how many square feet?
25,117.
Oh my God, that's a big house.
Actually, yeah, I didn't look at it that way.
Holy cow, 25,000 square feet. Man, they've got to have a lot more than 2 kids. Okay, so they're asking you what? Circuits?
It says considering no other loads, how many 120 volt 15 amp circuits are required for this residence?
All right. And did they say something about the bathrooms? Is that the one that's got the bathrooms in it?
No bathrooms.
Okay. Well, good. All right. So you're talking about not the 20 amp, you said, right?
Yeah, it says no 20 amp. It says considering no other loads, how many 120 volt 15 amp circuits are required for this residence?
All right. So let's talk about that. We're talking about receptacles, right? Well, we're talking about receptacles or just circuits, right? Is that what it says?
Yeah, it just says 15 amp circuits.
15 amp circuits. Okay. That's important. All right. So did it say anything about the 20 amp circuits or it just says 15 amp?
Just 15.
Okay. So, I mean, granted, in residential dwelling, it's either 15 amp or 20 amp, but on this test, they tend to call the 15 amps a certain, well, they call certain receptacles 15 amps for clarification or for clarity. And then they refer to other circuits as 20 amp rated receptacle circuits. So what they're doing is they're playing a little bit of games with the knowledge that you have residential dwellings and how we calculate receptacles, how we calculate circuits, how we do our demand factors and things of that nature. So this question has a lot to it, believe it or not. It's actually a fairly simple answer, but to get to the answer correctly, you have to understand all the pieces to it. So let me walk you through all the parts of it really quick, if you don't mind, because I think this will help you kind of clear up a couple of things. First and foremost, we're talking about a residential dwelling or residential calculation for a dwelling, right?
Correct.
All right, so that's important. I'm gonna erase all of this except for the square footage because that's really all I really want to keep on here. Right? Can you see my screen?
Yes, sir.
Okay, and that's clear enough for you? Okay. All right, so we're talking about with residential dwellings, when we're talking about service calculations, well, actually, when we're talking about calculations, we could be talking about service calculations, or we could be talking about branch circuit calculations, okay? A lot of times, the calculations for both of those are calculated the same way, but the difference between the two of these in your code book is that we have a bunch of derating tables and derating factors that we can apply, but those typically only apply to service calculations, okay? And that's an important distinction in this particular question. So first and foremost, and let me walk you through that part in your code book. If you look in Article 230, so I'm sorry, 220, excuse me. So 220, it starts on page 70. And a lot of guys don't pay much attention to the parts in an article, but those are actually really important a lot of times. And so they're the Roman numeral headings that break up an article into chunks, okay? So if you look on page 70 of your code book, and you look over on basically the left-hand side, you see that little table, that little picture diagram where the boxes are at?
Yes, sir.
So you see how it says part 1 is general, and that doesn't really mean much to us. But part 2 specifically says branch circuit load calculations, okay? And then right below that, it splits. It says part 3 and part 4, and I'll explain what those are here in a minute. But effectively, part 3 is feeder and service load calculations. So that's important to you because part 2 is going to calculate basically both the branch and the service calculations. But in part 3, we start derating those calculations that we did in part 2 with the stuff that's in part 3, but only for the service calculations, okay?
Okay.
Okay, now this one in particular is asking me about a branch calculation. So I'm only going to be in part 2 of Article 220. I'm not ever going to go past anything that's in part 2. Now, if you look on page 72, look on page 72, if you could look on the left-hand side down at the bottom, you will see part 3 listed right down there on the left-hand side. Do you see that?
Yes.
There you go. So anything that is in part 3, feeder and service load calculations, that's where we see all of the range table, the derating table for the lights, the derating table for the receptacle calculations. I mean, all of the derate tables and stuff occur in part 3. All right, so I wanted to tell you that. Now, the next thing we have to talk about really quickly is a really important chunk of the minimum requirements in a residential dwelling. And to do that, we have to get out of 220 real quick and go to 210.11c. And then 210.11c is a really important section. Now, it's not directly related to the answer to this question, but it's directly related to how you get to the answer on this question, okay?
Okay.
Let me go over here. 210.11c, going to be on page 60. I guess it's on the left-hand side, kind of toward the bottom.
Yes, I'm right there.
Okay, now 210, this is an important section. Effectively, it just says, look, if you have a panel that has electrical circuits in it, in a residential dwelling, you're required to have X amount of 20 amp rated branch circuits in that circuit panel. In other words, I've got a panel out in the garage for all of my, lights and plugs and stuff. The code's telling me, no matter what, I mean, I can have a bunch of 15 amp circuits if I want, but there's a few 20 amps that I have to have. They're minimum code, bare minimum code standards. And so I have to have 1, 2, 3, 4, 5 of them. Now let me explain what those 5 are. 2 of them are the kitchen countertop appliance circuit receptacle outlets. They're specifically for the kitchen countertops. There's 2 of them required as a bare minimum, and they have to be rated for 20 amps, right?
Okay.
And then I've also got one that's in the laundry room, and all this is spelled out over in the corner of page 60 at the bottom left-hand side. I'm also got one for the laundry circuit. Now, the laundry circuit, that's not the dryer. An electric dryer would be calculated separately, but this would be for the washing machine and any other circuit that's within the laundry room only. It can't extend outside the laundry room, so I can't feed a hallway circuit from it. It can only be with the receptacles within the laundry room that are, for the washer and dryer, maybe an iron or whatever you want to put in there, okay? The 4th one is a bathroom circuit. And I say the 4th one because it's the 4th one. It's not the 4th 3 or 4 or 5, however many bathrooms you have. The code only says I have to have 1. Now, I'd have 4 bathrooms, and I'd be allowed to still only have 1 circuit because then I could daisy chain all the bathrooms off that 1 circuit. Make sense?
Yeah.
Now, if I want to have more, obviously, sure, but I'm just saying from a minimum standard. So I got the 2 kitchens, I got the laundry, I got the bathroom, and then brand new for the 2017 edition, for goodness sakes, finally they got smart, and they put a garage circuit over on the top right-hand corner. Now, the garage circuit, I've got so many power tools in my garage. I'm surprised that I need really like 4 or 5 circuits in there. But at any rate, I got 1, and that's new for this year. So those 5, those are a physical requirement. I mean, I literally have to go open that panel board just like I've got right here and be able to see those 5 circuits over there, left or right, whatever I'm going to put them. But I have to have 5 20 amp circuits on each one of those, or each dwelling unit that I build a house or put electrical equipment in a house. Okay. All right, now, all that's important because these are all 20 amp rated branch circuits for receptacle power, okay? So that's why I meant earlier when I told you sometimes they refer to 20 amp circuits, sometimes they refer to 50 amp circuits. This is the distinction. These are the 20 amp circuits they would ever be talking about if they are talking about one on the test, okay? For residential.
Okay.
Now, so we're going to leave here. We're going to go back to where we were in 220. So in 220, we're calculating both branch circuits and we're talking about calculating our services, okay?
Okay.
Stop me if all of this, or if you know all of this already, but like I said, you kind of have to understand all these parts and pieces to really, understand a question like this, so that you don't get, taken off on the side. Excuse me. All right, now, I've got, so if you need me to repeat something, don't hesitate to ask. But so again, I'm going back to basically what we're dealing with here. So in Article 210, we dealt with the physical layout stuff. Article 220 is our load calculations, branch and service. And then, of course, we split 220 into Part 2 and Part 3, branch and no D rates, and then service calculations that are based off of Part 2 but have D rates in Part 3, okay? All right, now, so we look on page 71. When we're doing a calculation for residential dwelling, typically the very first step we do is we look at, okay, the table on page 70, which is 220.12, we want to figure out what's the volt amps per square footage for whatever occupancy type we're calculating. In this case, dwelling units, if you look on page 71 on the left-hand side, on the table there, it's about 5 or 6, 7 down. You see that over there on the left?
Yeah, 3.
Now there's a little tiny letter A right after the word units. You can ignore that. It just basically means that even though this table is just lights, that little letter A tells you effectively that this number that we're about to look at is both lights and receptacle calculations, okay? And that's important. All right, now, you look over on the far right-hand side and you see that number 3 there on the table. Yeah. That means that for every square footage, I'm going to have to take a value of 3 volt amps as a minimum load calculation for the lights, which is what that table is worded for, but also in this case, in dwelling units, all of the general purpose, non-specifically listed 20 amp circuits, which there you go, there's that line in the sand of the ones we talked about just a minute ago in 210.11, and then all the rest of the stuff in the house, which is the general, like the bedroom plugs, the hallway plugs, the living room, things, other areas are not specifically listed in that other section, okay? All right, now, these are, and here's what they do. They basically refer to these as effectively 15 amp receptacles. And it doesn't necessarily have to be 15 amp. You could put a 20 amp receptacle on it, I suppose, if you really wanted to. But effectively, that's what they're talking about, just to kind of make it clear. However, that 3 volt amps is multiplied times the square footage in the dwelling unit. Now, it's important to note that we don't include garages in that square footage, and we would not include any open porches or places that are not adaptable for future habitation or future use, okay? Now, that means that if I've got a basement that has a real short height on it where there's no way it could be livable space or adaptable space, I wouldn't worry about that. In this case, they're not really telling you anything about the square footage, so we're going to use all of it, okay?
Okay.
So my step to start this question then comes from page 71. It says, okay, those square footage, each one of those are going to be calculated a value of 3 VA. So I start out by taking that calculation, which is going to be 5,117 square feet, and each one of those is going to be 3 VA. So that gives me a calculated value of 75,351 VA. Okay.
All right.
Now, I'm gonna stop here because that's where this question ends pretty close. There's some other things I'm going to talk about here in just a second to kind of help close this out. But they're asking you for the minimum number of branch circuits that it would require for the 15 amp circuits. Remember, that's what we're calculating here with that 3 VA, or those 15 amp variety of lights and plugs. I don't have any way to separate them, so you could not ask me how many circuits are specific for the receptacles and how many of them are specific for the lights, because I don't know. We calculate them all in one lump sum. But I could tell you the circuits for those 2 items, if I wanted to do them at 15 amps at 120 volts, is that what the question said?
Yes.
All right, I'm going to take this number here, this 75,351, and I'm going to multiply that. Now I can do it two ways. I could either go over here and go, okay, 15 amps times 120 volts is equal to, I think, 1800 VA. And I do that because a volt and an amp multiplied together give me a VA, a volt amp. I mean, it makes perfect sense, right?
Yeah.
Sometimes on the test, they'll use watts. Sometimes they'll use volt amps. Same thing, don't let that worry you. So 15 amps times 120 volts. That means that every 15 amp circuit in that panel could handle a maximum of 1800 volt amps of load. Well, my other value that I've got over here, which is the 75,351, is already expressed in volt amps. So when I convert this over here, then I can just simply divide that by 1800. And to me, that's a little cleaner of a way of keeping it straight. There's another way you can do it, but let's just assume that we're doing it this way. So 1800. What my calculator says is that I need 41.86 circuits. One quick note, if I'm calculating out, like minimum requirements, in this case, the minimum number of circuits, let's just say, for example, we did that calculation, and it came out to be 41.0001 circuits. My answer would be 42 circuits, because no matter how small that fraction is, it's still a real value that I have to have a circuit for. So I can't ever round down any minimum calculation, okay?
Okay.
Whether it's this or any minimum branch circuit size, minimum wire size, I mean, minimum is always going to be rounded up. Maximums will always be rounded down, so watch out for that 0.5 business. Sometimes it can get in your way. Anyway, long story short, 41.86 circuits would be rounded up to 42 circuits.
Okay.
Is that one of the answers to pick from?
Yeah, that's one of the answers.
All right.
Yeah, see, I missed that 15 times 120, and
Yeah.
I didn't divide all that. So that's where I stopped at when I got the 75,351. I didn't know where to go from there.
15 amps? You just divided by 15 amps?
Well, I didn't know where to go after that. I just kind of stopped and left it at that.
Oh, so you got the 75,351. That's good.
Yeah, I got that far.
Now, some people, they don't like to do the conversion. What they'll do is, rather than what I just did there, give you the same answer. It doesn't matter. You can do it either way. What they'll do is they'll take the 15 amps over here. Oops, not eraser, pen. The 15 amps right over here. Still got eraser. 15 amps at 120 volts, right? What they'll do is they'll take this number and they'll divide it by 15 amps. Take that number, so I'd take 75,351 divided by 15. That would give me a subtotal of 5,023.4, and then they would divide that by the voltage of 120 volts.
Oh, okay, okay.
So, I mean, either way you do it, you still get the same answer, 41.86. I mean, for me, it makes sense to do the circuit and just get a lump sum for the circuit, but you can do it either way. Okay?
Okay.
Now, all right, now here's the catch. This is a branch circuit calculation. It's not a feeder or service calculation. So I just want to be clear with that, because if they're asking you to calculate the demand on a feeder, then there's one more step that would have been required. Okay? Now, in this case, they're asking for the number of circuits, so that's a different question, but they could use the same exact question, for example, and ask you, what's the demand load on the feeder for those circuits? That's where part 3 of Article 220 comes into play, okay?
All right.
So if you look on page 72, effectively everything that is in part 3, which is on the bottom left-hand side of page 72, almost all the stuff that you'll notice from here on out are mostly demand factors, or they're D rates, basically. And so let me back up and explain something really quick. I may ask you to give me these numbers again here in a minute, so if you've got those written down, I appreciate it.
Oh, yeah, I got them.
All right, let's just say that we had, well, I don't want to confuse you. So let's just say that we had the question was asking us when we got to the 75,351, was it?
So, I believe so. I didn't write that down.
No, it's okay. Here, I got it right here. I'm going to multiply it times 1,800. That's 75. Yeah, so 75,351. So we got that answer so far. This was the 3 VA times the square footage. So we got there, right?
Yeah.
So there's a really important couple of terms that you really have to understand, and they really hammer on these two terms on the master's test in Texas. You really have to pay close attention. And those terms are connected loads and demand load. Yeah. So you remember that from class?
Yes, sir.
Harped on that enough? Demands loads.
Yeah, some of it I'm pretty good with, but there's just these little things here and there, like you're saying, that's what's getting me, you know.
Yeah. You really have to pay really close attention to what, you know, the way they word it and what they're asking you. Because, I mean, it could be the exact same question, but they could be asking you for one value or another value, and the difference would be in that one word, right?
Yeah.
So, I mean, it's really important that you pay real close attention. But anyway, connected load would be your calculated load from the code book with no D rates. Demand load would have typically some demand factor applied to it. Sometimes demand loads can be bigger than a connected load. For in the case of continuous duty, where you increase it by 125%. But typically with residential calculations, we're derating it by some factor, okay? So what we're trying to do now, if they ask me for the demand load on the service, that's a specific thing they're asking me. They're saying, okay, we want you to look at this, and then we want you to calculate this number right here as the portion that would be on the feeders on the service on the outside of the house. So that's where the first table you look at on page 72 over on the right-hand side, 220.42 would come into play. And so this is the first of the derating steps for the standard method of calculation that we have in the code book. It's a very tedious, the standard method of calculation is very tedious. It's got a lot of steps. Every item you have to do by itself, and usually there's a derating or some table to apply to it at every step. This is the step for the lights, and in this case for residential dwellings, the receptacles as well, okay? So if I was doing a feeder calculation, this number here, which is the 75,351 VA, is not the complete number, because do you remember how we started this whole thing with those 20 amp circuits that were required back in 210?
Yeah, the 520 amps you had to have?
I had 5 of them, right? Well, there's a few of them that we worry about, a few of them we don't. So the 520 amp circuits, they come into play when I'm doing a feeder calculation. I'm required by code to count 3 of those 5 as some sort of a value for my feeder calculation. So if you look on page 73 of your code book under 220.52A and then also B.
Yep.
Ones that we just talked about way back in 210.11C now have a value when it comes to feeder calculations that I have to include in these calculations. And that's going to be for the 2 kitchen appliances, which I'm required to count, and then the 1 laundry circuit. They don't say anything about the bathroom circuit or the garage circuit, because they figure in a house like mine, the bathroom circuit's probably not going to contribute that much to a feeder calculation, right?
Yeah.
And I think yours is about the same amount of hair. No, you got a full head of hair. No.
Me, I'm losing it, man. My kids, they say my head looks like the McDonald's golden arches.
Maybe on your calculation for your house, they'd have maybe 5 amps then. Is that what you're saying?
Yeah.
All right. Anyway, you get my point. We don't worry about the bathroom. We don't worry about the garage circuit when it comes to feeder calculation, but I do have to count the 2 kitchens and the laundry. Each one of these 3 has a load calculation in 220.52A and B that's 1,500 VA for each one of those 3. So I have to basically add 1,500 times 3 for the 20 amp circuits to my feeder calculation. Okay, so that comes up to be 4,500 VA, and that's an important number to remember, because you're going to have that 4,500 VA on any residential feeder calculation, whether it's standard method, optional method, whether it's a mobile home, an RV home, a house on blocks, a house on wheels, doesn't matter. So it's always added, because those 2 kitchen and the laundry are always going to be there. Multifamily included. There is one exception for that, but I don't want to get into there. But 4,500 VA, if it's a a house that's got a pot, a cot, and a hot, someplace to sleep, eat, and bathe, right? Then you have to have that added in there. So I'm going to add that in this case for a feeder calculation to the first step, which is the 3 VA times the square footage. So I'm going to add those two together. So just add 4,500 VA to that number. And I have to do that at this point because I'm going to derate both of these steps together in the same step, I guess. So that gives me 79,851 VA total so far. And remember, that's a connected load. That's a full code calculation without any derates. My derate comes from the table on page 72 on the right-hand side, 220.42.
Yeah.
And there's a lot of calculations in the code book that have, okay, there's a block of this number you can't touch. You're going to keep all of it. And then whatever's left over, we're going to derate by X amount, right? And that's the same way this is. Of this number right here, I am not allowed to do any derates to the first 3,000 VA of that number. Now, I have to get it out of my way, so I'm going to subtract it here, but I'm not subtracting it to forget it. I have to remember I'm saying I'm keeping all of that number, but I just move it to the side. So I'm going to take that 3,000 VA, and I'm just going to write it over here on the right-hand side, just so I don't forget it. Now, that's step one, basically, or the block one there. And I get that number right there from the table on page 72. It says the first 3,000, 100%. That's what that means. And then everything else is left over. The 7,500, 851, or 5,000, 851 VA that's left over. That's the block that line 2 there says take a 35% swipe at it. It's a big hit. I mean, I'm throwing 65% of that number in the trash. So it's a big derate, but it is a derate nonetheless. So minus 3,000 gives me the 76. 851. I'm glad I did that on my calculator just to double check myself. And then that's going to give me times 0.35. So that gives me a balance of 26,898. Yeah, I rounded up like 98 VA. Those two have to be added back, which would be 29,898 VA. And that would be my minimum calculated load for the feeders, given all of the receptacles and the lights that are required to be in that dwelling. Okay. It's probably more than you wanted to know. It was more than what that question asked, but you have other questions that are similar to this where they're asking you for feeder calculation. So it's important to see how it all fits together. That way, no matter what they ask you, you know how to deal with it, okay?
Well, I remembered that 4,500 in class. I forgot that when you do calculate the feeder load, it only requires 3 of those.
Yep.
So that is something I forgot.
Yeah. Yeah, if that question would ask you for the 15 and the 20 amp circuits, well, there's 3 more 20 amp circuits you'd have to add that number. It would have been 42 for the 15 amps and the lights, plus the 3 that you have to have in the kitchen. Well, no, I'm sorry. If they're asking me for the number of circuits, then that would have been 5 more because I'd have to count all 5 of them. But if it's a feeder calculation, only 3 of them actually have a load calculation associated with it.
Okay.
Does that help any?
Oh, yeah.
That's just part 1 of a service calculation for residential dwelling when it comes to the standard method. After this comes the dryers and the ranges and the air conditioning, the heating equipment, fast in place appliances like water heaters and other appliances that might be fast in place, dishwashers, trash compactors, refrigerators, whatever else that might be in the dwelling unit.
So do you do all those separate, right? Those are all done separately.
Most of the time, I don't think on the master's test recently I've seen too many of them that have all of these things put together in the same question. So probably you would see them in piece by piece by piece. I don't mind going over the rest of them with you, but I don't want to just go off on a tangent because I want to make sure that I'm covering whatever your questions are. I just want to basically just kind of remind you that there's a lot more to service calculation. Now, this one in particular, if I was looking for, just to wrap this up, if I was trying to size the wire for it in the ground wire, or the ground electrical conductor for the service, right? Just one more quick little step. If I wanted to know what size feeder would I have to feed this service with, and what size ground electrical conductor I'd have to run from the panel to my grounding system. So I would divide that by what, do you reckon?
240.
240 volts is nominal voltage for residential dwellings. I'm going to erase a bunch of this other stuff. just so I have some room here. So what does that give us if we divide that number by 240?
So 124, 575.
What? Oh,
Or
I didn't. You know what? I almost messed up. I didn't add my 3,000 back. I'm glad you said that. 29,898 divided by 240. 124.5. Now here's where that 0.5 comes into play. I would round that up, be 125 amps. That just so happens to equal a standard service rating. You're asking yourself, what's a standard service rating? How would I know what those are? Well, look on page 95 of your code book, and you'll always have a nice table that tells you exactly what the standard service sizes are, because they happen to be the same as the standard breaker sizes are. So page 95, 125 amps is the standard service size, so we're good. But had that number been 130, let's say, for example, then I would have to round that up to the next standard size breaker rating before I did the wire calculation. Okay?
oh yeah.
Okay.
Yeah.
In this case, I'm good. 125 amps is good. Now, page 150 of your code book is your wire ampacity table, right? But I
Yeah.
want to caution you, remember, 150, I'm sorry, page 150 is not for residential feeders. So you have to be careful with that, because that would, potentially throw you off. So if you look at residential feeders, what we're going to do for those is we're going to calculate those on page 800. Okay.
Page 800.
Yeah, page 800. And that's a way far off from where we are right now, but that is where we would go, page 800. And that is the table that used to be in the code book that they took out, but then in this edition they brought it back. But they put it back in the annex. So we go back to page 800. And that's going to be something you have to remember, because if you have any residential feeder calculations, you're going to need to know where the table is. So make sure you jot that down, or just memorize it or something so you can remember how to get back to it. But for 125 amp service, I'd have a number 2 copper. If they don't ask me one way or the other, I'm always going to answer in copper, so it'd be number 2 og. That's rated for 115 amps if it was commercial, but with residential, they give us a little bit more, basically another size up of ampacity. So number 2 would be perfectly fine.
Okay.
5 amp for residential running. What size ground electrical conductor would I need for that service?
That's another thing, that finding that size is what I'm having issue with too.
Okay. So grounding electrical conductors, GECs, and EGCs are 2 different ground types, right? Or ground wire types. The GEC is the service. The EGC is the branch. Ground electrical conductors are going to be based off of a wire size, and the EGC, which is the branch circuits, will be based off of breaker size. In this case, we're sizing the service. So the wire that we're talking about right here is the service conductors. We're going to be looking at those wire sizes to calculate the ground wire, and we're going to go to page 116. It's 250.66.
Okay.
So based off of a number 2 copper conductor, what ground wire would I need for the GEC?
Number 8.
Number 8 is correct. What if I wanted to derate the neutral? Because I'm a cheap son of a gun, and I don't want to spend a penny more on this service, because I got to do 5,000 houses this year, and I want to do them as cheaply as possible.
Oh man.
Neutral conductors. What do we call? What is there? Let me ask you this. This is something that for a long time I was confused about early on. So we're talking about ground wires, right? We're talking about green wires. We're talking about bare wires. We're talking about a green wire with a yellow stripe on it. On a test, they're liable to call a ground wire a ground. They may call it equipment ground. They may call it a branch circuit ground. They may refer to it as grounding wire. I mean, basically, grounding wires could be either grounding electroconductors. They could be equipment grounding conductors, or they could be supply side bonding jumpers, system bonding jumpers, main bonding jumpers. So I'm just going to put jumpers here. So we have effectively three groups or three types of ground wires. We have the ground electrical conductor, which is your service. And then we have the branch circuit stuff, which is here. And then this is going to be basically the same as a GEC, but if you have, like, for example, if you have a transformer in the middle of a distribution system where you got a panel feeding a transformer, and then on the other side of the transformer, you don't have a breaker in front of that wire that goes to the panel. So how do you size the ground wire that goes between the panel and that transformer? And because there's no breaker ahead of that wire, that basically we usually use the tap rule to size that. That would be a jumper, and that's a separate table. So we're just going to call it, call it jumpers, basically, because that's what you'll see on the test. All right. Now, GECs are on page 116, EGCs are on page 124, and jumpers on page 119. Okay. I asked you for a GEC, so you went to page 116, and you found that it's based off of the wire size.
Yes.
And then if you're looking for a equipment grounding conductor, you would go to page 124. I'm sorry, I said 124, I meant 125. Sorry about that. Page 125, and that's 250.122, and it's always based off of breaker size. Okay. Now, I showed you all this because the question I asked you was, what if I want to derate the neutral? Well, all of these are grounding terms. Officially we call a neutral conductor, well, we call the white wire, we'll call it that. The white wire or the gray wire in a system, we don't call it a neutral a lot of times. We call it something else. We call it do you know the term?
It's it's right there, man. I can't think of it.
Grounded.
Yeah,
And a lot of
ground.
guys get that confused because they look like the same word almost, and you really have to know the distinction to even pay attention to that. But a grounded conductor and a grounding conductor, night and day difference. Different operations, different roles, different expectations, different tables. I mean, there's huge differences. However, the grounded conductor is the white or the gray wire. That's really what the official term for that wire is. It's not a neutral unless it's a multi-wire branch circuit where you've got two phases that share that white wire. So an A and a white wire, like if I got a black wire going to a circuit and a white wire coming back, that white wire is not a neutral, it's a grounded conductor.
Yeah.
Okay. Now I ask you for the neutral, which would be effectively the correct term for a grounded conductor that's part of a service, because there's two phases there, an A and a B, and you've got the neutral that's the multi-wire, share between those two. Where would I size that up? Well, I would calculate it out based off of some other calculations, or in lieu of that, I would use the table on page 119. And what do you see if you look on page 119, the table that's right there, 250.102C1? What is the first term that you see on that table?
Grounded conductor.
There you go. That is basically my minimum neutral table, if you really want to look at it that way. It's also my supply side bonding jumper table, my system bonding jumper table, so on and so forth. I mean, we use it for grounding conductors as well as grounded conductors. But that, I'm sizing the service. I had a 125 amp breaker, which is what I told you. We had a number 2 AUG conductor. We had a number 8 GEC. And if I wanted to derate the neutral, according to this table, that would be a number 8 as well.
Okay.
Now, I'd also have to calculate my actual loads on that neutral to make sure that that number 8 is large enough to carry the neutral loads. So in this case, my neutral calculation would probably be larger than that. But as a minimum size, not knowing anything else, number 8 would be the minimum neutral conductor or grounded conductor. So there you go. I'd have 4 wires there. I'd have a black, a red, or whatever, and maybe it could be a 208 volt 3-phase for condos or something. Could be red and blue, whatever, but some combination of those two, and then a white wire and a green wire, or black wire with green tape on it.
Well, let me ask you this though. Everything that we've just been going over,
Huh?
Has this all been residential only?
True, yes and no. The last three tables would be commercial or residential.
Okay.
We don't normally derate grounded conductor neutrals in a commercial building, but so that mainly that part of the neutral derating part would probably most likely apply to residential only, but yeah.
Okay.
All right. What other questions do you have? I went way deeper into that than.
No, that's fine. I've been having some issues with the dwelling units. Let me see here. I had some other stuff written
That's
down.
is that the only thing you have issues with? Because man, you're lucky. I got all kinds of issues.
I wish it was. Let's see. Question 4. I got that one. Question 4.
How do you feel about the?
I got a question here about this motor. It was asking a non-time delay fuse for a 5 horsepower, 230 volt, 3 horsepower motor. Now I got all the math right. It's 15.2 amps and
Non-time delay or time delay?
non-time delay.
Fuse. Is that all they're asking?
Yeah, for a 5 horsepower, 230 volt. Yeah, you got it. So,
Okay.
um,
Step one,
well,
FLA,
15.
FLA, which is what you gave me just a second ago,
Yes, 15.2 amps.
and you got that from page 320.
322, I believe. Yeah.
The FLC value, full load current, 15.2 amps. Let's just double check just to make sure. Not that I don't believe you, but just I don't give you the wrong. 430, page 320, 5 horsepower, 230 volt would be 15.2. I agree. All right. And
Okay. And then it's asking for a non-time. It's 300.
Okay, and you got that from page 308, 250 or 350. Sorry.
Yeah.
30.52. Non-time delay is 300%.
Okay, so that comes out to 45.6.
45.6 amps. Now what do you do?
That's where I didn't know. Now I had your answer sheet here, and you've got 45. I was curious of why you round down on that.
Okay, that's actually a really good question. In the field, I would put that on 50 amp. On this test, I'd put it on a 45 amp, and that's the honest answer.
Yeah.
Okay, well, why would you round up in the field and why would you round down on the test? Well, I'm glad you asked. Do you remember me telling you that about the artificial rule about exceptions on this test? There's a rule, in case you don't remember, there's a rule on this test that says you're not allowed to use exceptions to formulate answers unless they specifically, in that question, direct you to use them.
Oh, yeah, yeah.
Right? All right, so the table on page 308, the number of that's 430.52, okay? If you flip back one page to the instruction manual for that table, it's going to be on page 307 on the right-hand side at the very top of that column. So the same table number, which is 430.52, the article number that matches that is right there on the top right-hand side. It says under section C, the rating or setting for a breaker or fuse, a short circuit or ground fault protection device, which is the terms they'll use on the test. So just get used to that. They don't always use breaker or fuse. They'll say short circuit or ground fault protection device. At any rate, the rules in C1 very specifically say a protected device that does not exceed the calculated value in accordance to the table. 430.52C, which is on the next page. So what they're saying is, okay, if I calculate out using this 300% on that table, I have no choice but to round that down because I can't use a value or breaker that exceeds that calculated value right there.
Oh, okay.
And you're going, wait a minute, didn't you just tell me you'd put a 50 amp on it?
All right.
WTF, I mean, what's wrong with this dude, right? So right below that is exception number 1. And exception number 1 says, what we just said in the rule, forget about it. Go ahead and round up if you want. Read that for a second. See if you believe me.
Where on
the right-hand side of page 307, or exception number 1.
See, exception 1.
It says, and I'm reading it exact. Ignore what we just said, and if it doesn't match its breaker, go ahead and round up. What the heck? Might as well. I mean, that's effectively what they mean. It's the stupidest thing in the code book. They tell you, don't you dare round up. But yeah, never mind. Go ahead and round up. It's okay. I never understood that. It's stupid. Just tell me to round up and be done with it. I mean, that's typically what we usually do with breakers anyway. But PSI plays games with this because they know that they have this artificial rule on this test, and it's only Texas that has this rule that I've ever seen. Out of all the tests that I've taken, all the states that I have, Texas is the only one that has this rule. It says ignore exceptions, and you have to ignore them at your peril. You can't. And this is an exception to round up, so I would have to round down just because the rule is don't exceed that calculated value. Now,
so I have to watch out for that.
You have to watch out. I'm not telling you that they won't tell you to use exceptions, because they could give you the exact same question and say, in regards to exceptions or using exceptions or along with exceptions, then my answer would be 50 amps.
Okay. Does
that make sense?
Yeah.
Really have to pay attention to that, because I'm telling you, I've run across some people that really knew what they were doing, and they kept failing their motor section because they weren't hip to the exceptions being not part of the game unless they specifically tell you to use them. So, right. I think you already knew the answer to calculate this, which is good. I mean, that tells me that you're getting there. You were lost in that last little detail there, which is, at least I feel confident that you know where the tables and FLA.
Yeah, I kind of got that. I mean, there's some other motor questions I did pretty good too, but yeah, that rounding down, I guess I didn't, relay back into that article and read those exceptions. That's what got me there. Okay, let me see what else here. Okay, well, number 12. Well, I found that's the that had to do with the 3-phase ranges. And I found that table on page 798 where that's just a standard value or standard number, correct?
Yeah. I could show you how they calculate it, but you don't want to know.
No, that table will have it there.
Man, we don't really have very much time to calculate or do ranges tonight, but I do have a new video on YouTube that has to do with ranges. So if you have time to watch that tonight, please do, because it goes through every range variation that I'm aware of practically. And so, it's a good material to watch if you have time.
Okay, yeah, I'll definitely check that out.
Go to YouTube and type in my name, Mitchell Tolbert, and it should pop up.
Yeah, I went on there the other day and seen a couple, man. I had some downtime at work, and I kind of watched a few of them. And
they weren't the dancing unicorn one, was it?
I came across that one. Let's see that one.
Without taking the test and failing, it's kind of hard to know what your strengths and weaknesses are going to be going into this thing. So.
Yeah, I don't have my hopes set too high, but I took the journeyman's on my own, and when I found the category, the areas, I didn't do too well, and I studied up on those, and it took me 3 times to pass it.
My suggestion would be, if you can, I always tell guys to take a notebook and a piece of paper, a pen or something, and leave it in the front seat of your truck. When you get out of the test center, pass, fail, whatever, just before you call baby mama and tell her you passed or failed, just jot down whatever you can remember.
Yeah.
I'm not asking for full questions or anything, but if you know a couple of questions that you had some keywords that you had a hard time finding or whatever, if you can jot some of those down, I can help you, after the fact, kind of figure out what went wrong. So.
Okay.
You have to do it before you leave, though. You have to do it right then and there, or it'll just fly.
Yeah.
Yeah. First guy to cut you off in traffic, it'll be gone.
All right. Well, man, that was just so much, man.
And there is a lot. Listen, don't overload yourself. Just you got services down well. I mean, just you'll be okay.
Yeah,
Um,
I'll go back over that this evening. I mean, I do fairly well with go flipping through the code book.
okay.
That 2 minutes per question might get me on a few, but
It's tough.
but the math is always kind of what got me. But I've gotten a lot better with it, and especially after taking your class. I got the motors down pretty good, but there's just that little rounding up, rounding down, exceptions, this and that, and
Did you write down a bunch of notes on the motors and stuff in class?
yeah, I got some notes on the motors, and I've been the questions that I on your practice test. I kind of nailed those motor ones pretty good. Besides that one where you had to 45.6, you had to round down, but
Good.
with seeing that exception, I understand now.
Now, and remember, you wrote some stuff in the front of your book in the table of contents. I urge you to use the table of contents as much as you can. If you have any question that looks like a wiring method or wiring material, a chapter 3 thing, man, that table of contents is so much better to try to use. And then you put a bunch of notes about motors on page, 4 or something.
Yeah, I remember writing all that down there.
And so another thing I like to use that for is, I think on page 9 or something, there's some blank spots after the last little part. Page 8, right? Like the table that we mentioned a minute ago, page 800, which was the residential range table, and
Yeah.
then the table or the page that you had that 3-phase range deal on. I mean, any of those pages that you want to try to remember, I would jot them down right there with just a short keyword of what's on those pages. Page 95 for my breaker sizes, page 150 for my wiring capacity, page 116 for GEC. You know what I'm saying? Just to kind of give you a good fast nudge, because you can look on page 9 and then just run your finger right down the end of at the bottom of the book until you hit that page, and boom, you're there. So I mean, it's a good handy. It's a good investment of your time this evening if you do that. Remember, every question counts the same points, right?
Yeah.
No matter how you want to do the code sections, it's really up to you. And honestly, with 2 minutes a question, you don't really have a lot of time to waste, right? So I don't want to steer you wrong and tell you to go through all of them and put them in different piles like we used to do, because you really just don't have time. I mean, it takes about a minute just to read a question and figure out what they're asking you. So it really crunches down your research time. My suggestion would be to keep an eye on that clock mentally. Every time you hit the next button, you just need to look up there and see what minute count you're on. And then when it gets down 2 more digits, you need to be picking and moving. And if you don't feel comfortable about it, go ahead and answer it, but flag it so that you've at least got it marked, okay?
Okay. Yeah.
You know what I'm saying? But what you cannot afford to do is get stuck on any question for any length of time.
Yeah, and I thought about that, and I was kind of like you're saying. If I see a question that's somewhat similar and something I've seen before, I'm gonna go get after it pretty hard. But if it's something that's completely off the wall to me, then I might just mark it and come back.
Right, skip it.
Yeah.
I would just skip it, because so if you don't mark it, right, and you don't answer it and flag it, right, you can skip the question, and still by the end of the time you're done, let's say that you skip 5 questions because they were just really hard ones, or you don't even know what they're asking, right? Instead of answering them, just leave it blank and hit the next button, right? When you get down to the last question, so there's 75 total questions on the code calculator or the code section. Only 70 of them count, but there's 5 of them they just throw in there. But at any rate, when you get to the last one of those, you go to the go-to button at the very top of your screen. And when you hit that go-to button, a window will pop up and say, okay, which category of questions do you want to go look at? And you can pick the unanswered category, so it will take you back to that very first one you skipped. So you
Okay.
can have a way to quickly go back to all the ones that you skip when you're going through these. And that's really a good idea. So if you get stuck on a question, don't mark it, don't answer it, just skip it, just keep on going, find it. But you've got to keep an eye on that clock. You can't get stuck on anything because that's the key there. Because if you burn up too much time and you got a bunch of them that you skip, then you're kind of hurting yourself, right? So
Yeah.
you got to process. If you get stuck, and trust me, I know the temptation to think, man, I'm almost there. I'm almost there. Give me one more minute, and then you spend one more minute, and you're still like, I'm almost there. I mean, it's, you know what I'm saying?
It agitates you.
But you've got to walk away. You got to say, you know what? I don't have time to screw with this one right now. I'll come back later. You got to be
Yeah.
able to have that snap in you, right? Okay, so when you're going through those questions on that code section, keep moving, keep moving, keep moving.
Okay.
If you can't find it in 2 minutes, skip it, and then you come back to the end, whatever time you got left over. Just go to that go-to button, go to the unanswered group, and it will literally take you to the first one that you skipped. And then when you hit next from then on out, it will just take you to the next one that you skipped. So you won't ever see any other questions, in your way.
So were you serious about on the math part? You can't take any paper in there no more. You got to use them boards.
That's correct. I wish I was joking.
Man, that's so stupid.
It's not a funny. It wouldn't be a funny joke. Be the last one in the room. Ask nicely. Tell them it's. I got to have paper and pen because I have a dyslexic mentality. I don't know. Just whatever you can try to.
I'm left-handed. I'll throw that in there and see if
There you
they'll
go.
bite.
Southpaws are notoriously big sloppy handwriters.
Yeah.
No, just tell them you have a learning disability and it's really hard for you to visually see that background. I don't know. Or take them some Twinkies and a soda and growlers at them or something.
It might work.
I'm gonna tell you, I've actually heard people tell me they used to do that. Like they'd take their test on a Saturday and they'd bring donuts and stuff and put the test in her.
Oh man.
I mean, trying to pass a test, I mean, anything goes, I guess, huh? But
Yeah.
well, get some good sleep tonight. Don't stay up until you're just sick of it. Try to watch that range video if you have time. It's about an hour and a half, so it's long.
Okay.
But I mean, it's everything you ever want to know about ranges. So if you feel like you want to brush up on that, look at it this way. On that calculation part, if you could nail the branch circuits, meaning the ranges, the dryers, the service calculation for residential dwellings, I mean, those are 3 fairly complicated parts. If you could nail those 3 and then get several of the other ones, you might not be doing very bad. And I'd rather be an expert of those 3 and get some of the other ones fairly right than be half-assed across all 3 of them. You know what I mean? Or half-assed across 10 of them, I guess is what I'm saying.
Yeah.
So it might not be a bad idea to focus on what you already know, the range or the service calculation we covered tonight, and then delve into those ranges and dryers and look at Article 220 really closely, read it several times, try to understand how it all works together. Look at the option method calculation and try to understand that. I mean, that's probably what I would do at this point with what time you have left over.
Okay. All right. Well, Mr. Tolbert, I appreciate your time, sir.
And I'm sorry if we were a late start. I apologize. That just